fellow developers to a coding journey that will revolutionize the way you craft software. In today's episode, we're diving deep into the world of solid principles, focusing on the open-close principle. So buckle up as we decode this essential concept and uncover how it can truly elevate your programming game. To kick things off, let's get a grasp on what the open-close principle is all about. In a nutshell, this principle urges us to design our software modules in a way that they're open for extension but closed for modification. What does that mean? It means you can add new functionality without altering existing code. This maintains stability and minimizes the risk of introducing bugs. Alright, let's put theory into practice with some concrete examples and see hash. Imagine we have a shape drawing application. We've got our base shape class, and we want to add new shapes without altering the existing code. See how we're extending the functionality without changing the core shape class. This encapsulation keeps the existing code unchanged while allowing for endless possibilities. Now that we've got the hang of it, let's explore the benefits. Firstly, maintainability. Your existing code remains untouched, reducing the risk of introducing errors. Secondly, scalability. Adding new features becomes a breeze, enhancing your software's capabilities. And thirdly, collaboration. Different developers can work on extensions simultaneously, leading to efficient teamwork. Of course, like any programming concept, there are pitfalls to avoid. One is over-engineering, where you create excessive abstraction. And remember, don't try to predict all future changes and focus on what you need now. To succeed with the open-close principle, keep your classes and modules focused, test thoroughly, and embrace the beauty of interfaces. And there you have it, developers. The open-close principle decoded and ready for implementation. By adhering to solid principles, you're not just writing code, you're crafting elegant solutions that stand the test of time. Now, let's tackle some common interview questions beginners or advanced might face. Beginners, we've got you covered. Imagine a shape drawing app where you add new shapes without rewriting existing code. That's the magic of the open-close principle. For interviews, you can nail it by describing this balance between expanding features and maintaining stability. Advanced viewers, let's delve deeper. Think of a banking system needing new account types. How can you extend it without causing a meltdown? That's where abstract classes, interfaces, and polymorphism come into play. Interviews love real scenarios. Now, get ready to conquer a few interview question answers, whether you're just starting or already an experienced coder. Let's go with fundamental question first. Can you explain the open-close principle in simple terms? Now, to answer this, you can say absolutely. The open-close principle is about designing software in a way that allows us to extend its behavior without modifying the existing code. In other words, we can add new features or functionalities without changing what's already working. It's like adding new chapters to a book without altering the existing ones. Moving to next question, could you provide an example of how you've applied the open-close principle in a real scenario? Now to answer this, you can say, imagine you have a payment processing system that handles different payment methods like credit cards and mobile wallets. To add a new payment method, you'd create a new class that adheres to a common interface. This way, the existing code that interacts with payment methods remains untouched, ensuring the principle is upheld. Moving to next question, now for those more experienced developers out there, how does the open-close principle contribute to code maintainability? You can answer this by saying, the open-close principle plays a pivotal role in keeping code maintainable. By allowing us to add new features through extensions rather than modifications, we significantly reduce the risk of introducing bugs in the existing code base. This makes maintenance easier because changes are isolated to specific extensions, leaving the core code stable. Moving to next question, now let's explore the potential pitfalls. Can you elaborate on some challenges you might face when applying the open-close principle? To answer this, you can say, one common pitfall is over-engineering. Developers might create complex abstractions or hierarchies, making the code harder to understand and maintain. Another challenge is striking the right balance between openness and closure. Being overly open could lead to a system that's hard to manage, while being overly closed might hinder future extensions. Moving to next question, now for the grand finale, could you walk us through a coding example that demonstrates the open-close principle in action? Now to answer this, you can mock some example like, let's consider a scenario where we're developing a notification system. We have different notification types like email, SMS, and push notifications. We want to add new notification types without altering the existing code. By using interfaces and creating new classes for each notification type, we can extend the system's capabilities seamlessly. If you found this journey as exhilarating as we did, don't forget to hit that like button, share your thoughts in the comments, and most importantly, subscribe for more coding adventures. Until next time, happy coding.